Ariel says, I love you. Oh, I love you too. Hi, honey. How are you? How do the planets stay in orbit around the sun? I think someone else asked a question. What's the purpose of Kamioka Observatory in Japan, or any neutrino observatory for that matter? I mean, we will be detecting neutrinos all the time, right? So the depends on which neutrino observatory. The different ones are at different energy regimes. So in particle astrophysics, we talked about the different types of particle, or sorry, the different type of, actually, yeah, particle physics or particle astrophysics experiments that can be set up at different energy scales and energy regimes. So some of them are lower energy, some of them are more high energy, some of them are high energy, some of them are ultra high energy. So you want to have a diversity of experimental setups so that you can do experiments at different energy regimes and learn physics at different energy regimes, as well as your sensitivity will be kind of different as well. So some neutrino observatories might be getting neutrinos only from the sun, some of them might be from astrophysical phenomena, some of them could be just leftovers from cosmic ray interaction, all kinds of different things. So by studying neutrinos, so pretty much the simplest answer to your question, whoever asked about that, was I think it was Alien who asked about this. The neutrino experiments, the main thing to note about them is the energy regime in which the experiment is happening, which will tell you different physics and different phenomena. If it's an astrophysical source for the neutrino, depending on which energy regime you're in, you will learn different things. So we have all kinds of neutrino experiments for that purpose. Okay? Because remember, just like we have the Large Hadron Collider, we have the particle accelerators, man-made particle accelerators here on Earth, we actually have natural particle accelerators in the sky. We have some very interesting, natural, exotic events and phenomena that happen in the sky in extragalactic sources. For example, gamma ray bursts. We took some time on some of the lives to talk about gamma ray bursts, which are actually gonna accelerate particles to very high energies. And so if you're interested in collecting neutrinos from sources like that, you'd have to be sensitive to such neutrinos, and your setup has to be different. Whereas if you want neutrinos from the sun, then that's a much lower energy regime that you are probing. Okay, so it's called probing different types of physics at different energy regimes. Okay, thank you for that question. Now let me talk about does universe will stay as long as humans' existence, or will it end at one specific time? That's a great question. It's more like the humans will probably cease to exist and the universe will be there. Steven, are you leaving? So let me give you some timeline. I think it was Siddharth again who asked that question. Let me give you some timeline. So we talked about galaxy mergers on the live recently. So our galaxy, which is a spiral galaxy, will be merging with our neighboring galaxy Andromeda, which is also a spiral galaxy. And this merger will be complete in approximately 6